Hey, what's going on, folks? It's Mike here, and welcome back to the Programming Language First Impression series, the series in which we take a look at a programming language for the first time, or rather, maybe a programming language I just haven't looked at in like 10 years, and, well, try to program in it and see what it's like from the beginner's experience, checking out the ecosystem, the community, and just where we would start with this programming language. Now, today's programming language is one that, well, I literally cannot do a series about programming languages without touching on this one. It's a purely functional programming language. Someone's probably told you that you need to learn it at some point in your life, and that language today is the Haskell programming language. So let's go ahead and dive in. I'm really excited to be looking at Haskell again. Again, I haven't looked at or had reason to write a Haskell program since my early days in graduate school, in which I briefly looked at it in a programming language course. But Haskell itself, let's just go ahead and start with the wiki entry here, which is a little bit down here. And then I've also Googled what I remember, and I do actually have on my bookshelf somewhere the Learn You a Haskell for the Great Good text here. And we're going to be looking at some of the resources. I tend to remember this being a great resource for learning Haskell, meaning it's written with a beginner's mind, or somebody who's new to programming, as well as new to functional programming. So anyways, let's just go ahead and take a look at the Wikipedia page here and learn a little bit about Haskell. Now let's zoom in just a little bit here. So it's a general purpose language, statically typed, purely functional. And what I seem to remember from my Haskell days is, this is the emphasis here, purely functional programming language, meaning, we're really trying to avoid state changes in our program, right? And we're almost looking at programming like a mathematician would with math, with how we assign variables. That's part of functional programming, as we found and looking at some of these different languages. But anyways, that's just something to keep in mind. So there's type inference here. So we can detect the types here. Lazy evaluation, so we can compute only when we need. That's oftentimes a nice optimization. It's been designed for teaching, research, and industrial applications. So again, Haskell is one of these languages, if you thought about what the reputation would be, or what the reputation of this language is, although this is changing very much so today, a lot of folks would just say this is like a researcher's language. And it's true, it has origins in that. If we see some of the big names who are part of this, let me scroll down just a little bit here. Like folks that I've run into at conferences like Principles of Programming Language, POPL, PLDI, Programming Language Design Implementation, or the functional programming conferences, these types of things here. Simon Peyton Jones is a name to know here, who's done a lot of work here. We're going to look into more of the folks here. We'll see exactly who has invented it later on the Wikipedia page. But these are a lot of the contributors, a lot of names that if you've studied PL or maybe you've bought a textbook or something, you might see like some of these names popping up, if not the authors, but as like editors and these types of things here. So anyways, that's just to say that Haskell, again, has had this reputation as a research language. And it's been used in teaching. Like I said, I first encountered it in a programming language course. But I think it is getting more industrial applications. And this could be coming in a variety of places, right? We famously saw languages like Camel, for instance, being used by Jane Street because of some of its safety guarantees and things that you can prove. And if you have a good enough compiler, the code can be fast enough for your needs. So again, the trick is with languages that we've looked at in this series, and sometimes you wonder, like, why doesn't everybody use it if it's a safer language, meaning generates, more correct code with less bugs and stuff. Part of it's what we teach in schools. That is one part of this. Part of it is, where can you find programmers who've learned that, which is usually a function of what you learn in school, what, textbooks are written in, and so on. And then part of it's just knowing that it exists. Again, Haskell is probably not something that you're stumbling upon for the first time unless, your parents are like computer science professors or something. I didn't stumble upon Haskell until grad school because everybody was talking about functional languages. In fact, that was new for me. So anyways, that's why we're going through this here. And it's just kind of interesting to think about the journey that languages like Haskell have taken from sort of research to teaching and then industrial applications now. So anyways, what's it got here as far as features? Type classes. Okay, so ad hoc polymorphism. Okay, we got to learn a little bit more about that. Type safe operator overloading. Interesting. Okay. I wonder if type safe means as strict as, in languages like C and C++, you can have a function that implicitly converts types, right? And implicit type conversion, meaning, it could be as simple as converting a long to an int or something, can cause a lot of problems, right? Whether that's with precision issues between different types, or truncation, or overflow, underflow, these types of things. So let's see how type safe it is here. And let's see, monadic input in monadic input output, or monadic IO. We're going to open up this tab here on what a monad is, because what is a monad, right? There's a couple good talks about that, and maybe we'll get into that in the tutorials here for Haskell here. But let's see. In functional programming, a monad is a structure that combines program fragments, functions, and wraps their return values in a type with additional computation. Okay, interesting. Okay, and then we also have monadic types, operators. Okay, so maybe we'll get into this a little bit here. Okay, it originates from category theory. Yeah, there's some computer scientists who I know who really are experts in category theory, and it's interesting that they think about things and program here. But yeah, maybe we'll get into monad here. Let's see if I just do a quick search here. Let me bring in another window here. What is a monad here? Let's see. Let me search here. This is just on the Haskell pages. Let's see. The monad class. Okay. Defines basic operations over a monad. Okay, concept from a branch of mathematics known as a category theory. From the perspective of a Haskell programmer, however, it's best to think of a monad as an abstract data type of actions. Haskell's do expressions provide a convenient syntax for writing monadic expressions. Okay, interesting here. So let's just kind of keep this in our mind. Abstract data type of actions. Okay, well, where do we have abstract data types? I guess interfaces. And actions. Okay, so it's some sort of like interface for doing actions or something. Again, let's see here. We'll have to think about this and probably practice what this is here. I don't know if we'll get to this in an hour. Everyone says they're super difficult, but maybe there's just, probably just got to practice. Like anything else. So anyways, monads show up in Haskell. Let's see. And it's named after the logician Haskell Curry. Okay, American mathematician and logician. Curry is best known for his work in combinatorial logic. Okay, very interesting. And we know there's such a thing as currying in programming as well, so maybe we'll get into that anyways. Okay, so Haskell semantics are historically based on those of the Miranda programming language. Oh, okay, cool. Another programming language maybe to take a look at here, Miranda. Okay, and still is pretty active here. Okay, by David Turner here. Okay, so we'll have to take a look at this here. Maybe in another video if folks want or are really curious. Let's go back to Haskell here. Okay, that's interesting. So that's where the semantics come from. I mean, it's interesting. I've always thought of, again, Haskell, again, 34 years, which is middle age, we would say, for a programming language. It's been around quite some time. But interesting to see that that's where it gets its semantics from. And interesting to see the developments here. A stable release in 2010, and then there was Haskell 2020 announced here. So I guess, which is kind of interesting here, maybe they do have a release cadence of every, I don't know. I mean, maybe it is just a really stable language, right, where you don't need to make too many changes, which is kind of interesting. So very interesting here. Let's see here. And that's where it had a formal specification. I see. So again, just looking through this from 2010. Sometimes with these research languages, they'll actually prove, like I think this is the case with ML, like prove its correctness. Okay, so that's why you don't get as rapid of feature changes, because they've proved it's like safe in some way or some property of the language, which is kind of interesting. So that's why you don't have a specification like, in C++, it's every 3 years it's sort of updated, or other languages are just, releasing new features as they please. So there's a little bit more maybe to this as far as, some of these languages are in a way I don't want to call it playground, but maybe a playground's the right term, or a sandbox for developing new ideas and trying out new things. But again, as we should probably emphasize, I'm sure there are Haskell programmers watching this or looking at this who say, again, yeah, Haskell is not just used in academia, it's being used in industry. Okay, so, and probably in places where I don't know. So maybe we'll find some of those here. But it is getting popular, 28th most popular programming language. So I'm willing to bet that some of you who have heard about Haskell or, again, thought it's important to learn. So anyways, okay, so after Miranda's release, long story short here, Haskell started getting developed, or folks started looking at it and wanted to extend and build their own thing here. That's essentially what I'm getting from this block here. So let's see, Haskell 1 to 1.4 here. Okay, let's see here. So they're giving us some feature changes, which we got to kind of take a look at here. In 97, you had Haskell 98. Okay, so there's been different like standards of this language here. And then Haskell 2010, I'm guessing, is like probably what most folks are learning or using. And then I guess there's a 20 version or something. Okay. So this was the spec here. Okay, so yeah, next formal specification 2020. Okay, so it's not quite a formal language spec, but it has a bunch of the like widely used extensions. Okay, so maybe 2010 is like the stable version, and then 2020 is like extensions that probably everybody uses or supports or something. Okay, so we've looked at features here. These, let me just highlight these for a moment for where I'm looking. These are the pinnacles. I mean, just glancing at this list of when I think about what is a functional programming language versus a imperative or procedural or object-oriented language, right? Usually I would say, if you asked me what is a functional language, I'd say something about lazy, it has lambdas, pattern matching, maybe list comprehensions, sure, type classes, type polymorphism, these types of things here, okay? Certainly, these first few features, I would say, are starting to show up in many other languages. Or, I mean, you can always implement these types of things, but, most languages these days have some sort of lambda or anonymous function. Most are getting some form of pattern matching, and then maybe like list comprehensions or other types of things, right? So think about your favorite programming language. You probably have some subset of these features, but again, these are things I tend to think of as functional languages. Now again, purely functional, again, sort of leans into avoiding state, right? So you could think of everything as being const or immutable. And if you want to transform your data, you need to, store that computation in a new variable or new place. Okay. So yeah, this is the concise way to say it. Functions generally have no side effects. Okay. Okay, let's see here. So pure function can return a side effect that's subsequently executed. So again, you can model impure functions. Okay. Yep. Let's see. Haskell has a strong static type system built on Hindley-Milner type inference. So this is like a algorithm or a type system, I guess, for deducing. I guess you could kind of think about this in languages where you have like auto for the type, like in C++, or languages that just infer the type. Maybe they use this. This is the one I seem to hear about from folks. But there's probably other algorithms, systems, and even ad hoc ways to make that work. Okay, let's see here. What else do we got here? We might just want to jump into Haskell. I think it's going to be a little bit interesting. Let me just end on this note here. The Glasgow Haskell compiler, GHC, is both an interpreter and native code compiler. That's cool. That is pretty cool here. Yeah, let's see its performance here. And of course, there's concurrency and parallelism. And in functional languages, because you're not having side effects, tend to lean in or do a good job with concurrency and parallelism. Let's see. I clicked on this. Where did it go? Computer language. Let's open one of these. Benchmarks game. Okay, there are a bunch of benchmarks here. Oh, not what I was expecting. Okay. Well, let's go back here. Let's see some of the code. Okay, so this is going to be for creating a module, our main IO, and then we're going to put a string hello world here, okay? And let's look at our factorial example. It's going to take a while just to, again, if you're like me and your brain was wired in C and C++, for better or for worse, sometimes you have to translate, which probably isn't the right way to think about things, but kind of just think about computation, again, as moving data around and putting it in places, I guess. So again, I want to be careful about how I talk about these things here, because I'm going to call them the wrong concepts here. Let's see. Let's see. Not needed in interpreter is default in a module file. So I guess, is this defining our main function? I don't know. And maybe this is a module. I guess maybe there's a module system. Again, we'll dive into the tutorial quickly here because I think I'm going to need it. Let's see. We have IO. And I guess, I mean, is this getting back to the monad thing? I got to think about this here, where we're like saying, hey, we want this ability or something like for this abstract or like type or interface or something, and then we want to put this functionality into it. I'll have to think about that a little bit here. Okay, let's look at factorial here briefly. Okay, so we're sort of defining the inputs and the output. And then using recursion with if then else expression. If n is less than 2, then this else. Okay, this looks pretty familiar to us. And then we're also just defining factorial. You know, if 0 is the parameter here for the one parameter, then give me 1. Otherwise, give me this. Okay. Oh, very nice here. And I guess they're giving me a few different ways to do this. Recursion with guards. Okay. So this is kind of a nice way to look at the pattern here. Factorial of just n. Okay. Otherwise, it's going to see if it passes these conditions. Otherwise, yeah, use this. Okay, that's kind of cool. And I guess this is where you get into, like, if you're proving a language, like for correctness, you could check if you have all of your edge cases, like all the values of n integers, right? N less than 2, and then everything else, right? They've got everything, you know, positive, negative here, you know, everything less than 2 explicitly, and then this. Okay, interesting. Using a list in the product function. Okay, so take the product of 1, 2, and okay, so product, you know, literally 1 times, you know, I mean, I guess this is like a factorial function here, and here's its parameters. Using the fold, which implements product, I'm going to fold, apply this function times 1 times, you know, whatever I get here. Okay, that seems reasonable. And point freestyle. Oh, interesting. Now this I don't know here. So fold right. So again, I'm looking sort of from the end of the list instead of the start, which is sort of fold L. Enum, let's see, 1.enum from 1 to 1 here. Okay, I gotta think about this one here. Point freestyle. I don't. Let's see here. Is star here? Okay, that's like a function I'm applying. Enum from to. Okay, interesting. So we got to think about this one a little bit more. And I notice there's no parameter here, so again, something's going on. Interesting here. Well, quite a lovely language that you can just implement factorial. And I guess this is the kind of power, I guess. I mean, it's going to take some getting used to for someone like me with a C background, writing out functions and sort of saying, hey, you know, you define this thing twice, but you know, you've defined it for 0 as an input and then n, you know, something else that it's, you know, matching against here. Like the second best match, right? If it's not 0, it's not going to match with this one. Which is kind of cool. It's kind of nice to think about this because you're basically specifying, you're almost writing your language like a spec, which is kind of cool. I mean, that's like a mathematician, right? Let x equals 0. X is just 0, right? It doesn't change here. Just like this factorial with the input 0 is 1. Okay, so anyways, I think that's neat. I think it's kind of interesting to rewire our brains a little bit. We're going to get into this, but let's just take a look at the website and the community here a little bit. I want to check. I mean, here's Simon Peyton-Jones. He's given a lot of great talks. I show my research students some of his talks on like how to write a research paper, how to give a research talk, and so on, which are very valuable. So if you're a graduate student watching this for whatever reason, search for Simon Peyton-Jones on YouTube, and you'll find some of his Microsoft research talks there, which I believe he was there or maybe was doing a sabbatical or something. And I believe he's now actually doing work at Epic Games on their verse language, which is kind of cool. So again, to see some of this functional stuff, again, I'll break the stigma, maybe help some Haskell folks, that Haskell is not just a research language, right? It's being used, and the ideas are being used in an industry, which is kind of cool. So it's advanced, purely functional programming language. So I can write declarative static typed code. We like static typing because then once we know anything is an integer, it's an integer forever. It usually helps when we're trying to prove something. Now this is brilliant here. There is a what is a monad video. This is probably worth like a reaction video, but let's just maybe answer that question. So anyways, it looks like a 20-minute video or something. You can pause this one, watch this one, and then make sure to come back and see what else we do here. So that's kind of cool here. Let's see here. Haskell unfolder, Dijkstra's shortest path. Interesting. Is that taking me? It's taking me to YouTube. But that might be kind of fun, again, if you're like me and thinking C or C-like languages for the most part. Systems languages, I guess. That might be kind of fun to watch and maybe compare. So anyways, it's cool to see they have these videos and really, what are high quality videos here by some, top folks here, John Hughes, Graham Hutton, like faculty and, researchers, Simon Peyton Jones and so on. Which again, I'm not sure if I'm supposed to credit Simon Peyton, or rather, again, I'm not sure if I should credit Simon Peyton with popularizing Haskell. I know he's one of many of the inventors. I don't know who actually. It wasn't clear from the wiki who invented it first, but we'll just go ahead and show this list because there have been many folks. Again, some of these folks I have met in person or seen at conferences, which is kind of cool. So anyways, let's just give them all credit here and start working through Haskell here. Let's see, testimonials here. Imagine AI, smart code generator, smart contract system, binomial. Let's see where else folks are using this. This is kind of cool here. Again, I like when programming languages show off some of the tools that they're building. I think that's just sort of inspirational and useful. Let's see here. Mercury. So it seems like a lot of, let's see, highest traffic features of no red ink here. I'm just trying to see what these are, like if they're more like back-end services or contracts and like proof-based stuff here. Foxhound Systems. I'll have to look at all these companies, I guess, here. But anyways, you got a good chunk of folks who are using this. And I've known folks at places that I've worked who will just write, little programs or scripts and stuff to do or help them do the work in Haskell too. So I know it's being used all over the place, in big tech in that regard, because I've seen folks and had to run their, Haskell code at the least in some like system, which is kind of cool here. Now this is pretty cool here. It's explaining the features here, right? We talked about static typing here. All Haskell values have a type here. Okay, so that's kind of cool. Char int, the function here is digit, which takes a character and returns a bool. Sorry, that's just how you read that. I like this website design here. Purely functional. So again, telling you about side effects here. So you're sort of defining what square does, and it takes an int here. This is kind of interesting here. Again, I gotta just wrap my head around the right terms here the best I can. But it looks like we're defining the square function. Sorry, I can't highlight without clicking this thing. Square for taking an int, returning an int, and then actually giving the function here. Let's move in just a little bit for you. So there you can see. So that's kind of interesting here. And then here's string concatenation, 2 pluses. Okay, that's kind of new. I actually like that. I like having string concatenation be a different operator than plus, just so you know it's not a mathematical operation, right? Because addition, if I'm adding things, has different properties. It's commutative. String concatenation isn't. So that's why I like a different symbol. Let's see what else we got here. Type inference. So you don't have to explicitly write out types. It'll figure it out. Okay, so that's good to know. There is concurrency. Okay, let's see here. You can launch threads. Now, recently we've looked at Dart, which had concurrency with something called isolates, which were like threads following Erlang, which Erlang had the actor model. We've looked at other types of concurrency, other languages that have leaned into it in different ways with like coroutines and so on, like Kotlin and so on. So it looks like we just have thread-based concurrency here. And it comes with a high-performance parallel garbage collector and lightweight concurrency library. Okay, cool. lazy functions, and we have a bunch of packages. Cool. So we can do a bunch of cool stuff here. And we've got a lot of what looks like wrappers like STL for graphics. Again, that's what many of you folks might have seen on this channel. Cairo for like vector-based stuff, I think, graphics. GTK for widgets. Quick check for property testing. This is a automatic tester here. I think it proves something about the correctness of your program, if I remember correctly. I had read the original paper a long time ago, but anyways, so that's kind of cool here. And you've got some different data structures and so on, ability to work with HTML data. So yeah, there's 6,954 packages freely available. Cool. So there's lots of stuff here. Okay, this is interesting. Fastly. Okay, I've heard of them as a content delivery network, CDN. Galo, geez, I'm gonna mispronounce this. Galois or Galay. Yeah, they're a company I've known for a while that has used. Okay, so there are Haskell folks there for sure. Okay, and these are some of the other ones here. Okay, interesting. DreamHost. Alrighty. Anyways, there's a nice wiki here for learning stuff here. Let's just start with the 5-minute introduction here. We got 5 minutes, so type in the Haskell expressions here. Let's get some help here. Okay, music is math. To kick off, let's try some out here. Okay, let's make this nice and big here. 5 plus 7. Okay, that's my first Haskell expression. I got 12 here. Chris, no. Okay, we'll follow the tutorial. I was gonna type in Mike, but there we go. Hi Chris. Okay, that's a pretty name. Honest, you're getting the hang of this. Each time you're getting back the value of the expression. Okay. So far, just a number and a list of characters. So here's a number. I guess this is a list because it's in brackets. And let's see lottery numbers. 42, meaning life. 13, unlucky. 22. Okay, so another list here. You made a list of numbers. If you win, we'll split the winnings, right? Okay, so let's sort. I guess that's going to be the function. 42, 13, 22. Okay, cool. Let's see. So this is... Okay, so what is this getting me back here? I do want to sort Chris in a second, but let's just kind of parse this out. So here's my list here. I'm getting a number, ORD here. Is this the ordering function, like how to sort these? And then I'm going to get a list back of numbers, because that's A, which is a number type here. Based on this sorting rule here, I guess. So I wonder if I could, is there a way to supply like a argument? Wait, help sort. Can I do that? Not in scope. Okay. Well, let's sort Chris, and we should get a jumble of the letters alphabetized here. Okay. Watch out for jurors. You should keep their credentials for the police. Okay. My nemesis is 28 years of age. Okay. 28. So we're building some sort of, let's see, tuple. Okay, cool. It is called tuple, not a record or anything like that. It's tuples. It's our collection. It's a way to type a bunch of values together in Haskell. Put as many as you'd like. And we can mix the types here, right? So that's fine here. All right, let's say our villain is this. How do I get our age? FST. So is that for first? Okay, so return 28. Okay. Good job. You got the age back of the tuple. The FST function just returns the first value. It's called FST because it's used a lot in Haskell, so it really needs to be short. Yeah. Let's see. If what I remember from my doing a tiny bit of scheme back in the days, right? You have these operations for getting the first or the last element, like the cons operation and so on. Or no, I think cons is getting a pair. I think you could just do like first as well, something like that. Okay, so that's cool here. Time to take the rest and see what you've learned here. Functions could be used on a list of any type. We can stuff values into tuples. Getting the values back from tuples is easy. Okay, so now let's say you want to use a value more than once. Sorry, I'm scrolling down just to make sure you can see. How would you do it? To make our lives easier, we can say let, okay, let, sorry, I'm gonna make this just a tiny bit smaller, x equal 4 and x times x. Okay, so, okay, I guess this is just assigning, interesting, 16 to this number here. So if x is 4, right, 4 times 4, now I guess if I just put x in here, that should just give me 16, right? Okay, well, we got to figure this out here. Let's see, you just bound a variable. That is, you bound x to the expression 4, and then you can write x in some code, and the body will mean the same as if you had written 4. Okay, let var be an expression in the body. Okay, the in part just separates the expression from the body. Oh, I see. Okay, yeah. So yeah, this is the body. This is the expression. For example, try let x equals 8 times 10 and x plus x. So this should be what, 160? Yep. Okay. So if we wanted to get the age of our villain, we could do let villain. Okay, I don't know. I'll spell it the way they do. Equals 28 occurs in first villain. Okay. Sorry, let's get this just a little smaller so you can see everything on one screen or one line. Okay, so again, just trying to understand, here is our expression. So this tuple, and for the villain, the body, we're saying, okay, this villain's going to represent the first thing here. This is going to give us 28 here. I actually want the second part, I think, but let's do it here, and I get 28. Okay. Now let's take a short detour to learn about the syntactic sugar. Try typing this out. Okay, a colon, and then the empty brackets, which I thought were a list here. No, we don't want to skip anything yet. You constructed a list. Okay, well done. That was tricky syntax. Use the colon function. Okay, great. It takes two values, some value and a list, and constructs a new list out of them. Okay, yeah, we call it cons for short. Okay, this is what I was thinking of. Okay, so I took this, I used the colon cons, and I constructed from some value in a list, a new list out of it. So A is in my list here. Okay, so A is a character, empty list, so tacking A at the start of an empty list just makes a list. Okay, great. Thankfully, we don't have to type it out. A, colon B every time. We just want to make a list of characters so we can use this. Okay. Let's actually do that though. A colon B colon C. I'm constructing this thing into an empty list. And I get A, B, C. Okay, but I could of course just do A, B, C. Okay. Excellent. Okay. And we have the equals operator to compare these. B. Okay. So I construct that with this list here, and then I want to test, and I guess I'm going to get a Boolean back here. Well, that's what I assume as a C programmer, right? This is testing for equality, but is it going to... Let's see how it's constructing that. Oh, it's just going to give me true as the bool here. Okay. Handling this syntax really well. Nice. Okay, you just get a Boolean value back, and it said true. That means they're equal. One final demonstration here. Okay, yeah, let's do it. A, B, C equals ABC. Okay, so strings are just, I guess, immutable, lists here or something. That's a way to think about it. Okay, lesson 3 over. Syntactic sugar is sweet. Yes, indeed. Okay, very nice. In A colon brackets, colon is really just another function. I like that. That's actually something I think about, again, in some of my other tutorials, especially when I talk about, it becomes apparent in languages where you have operator overloading, like in C++, where you're doing operator plus, operator minus, these types of things, that plus, minus, it's best to just think of those as functions. So again, that kind of makes this more natural here when I'm just talking about this in Haskell or whatever, just to think about every symbol that you're adding in as just some sort of function. Okay, I mean, yeah, it's a plus sign. That's what we think about it. It's doing a function. It's telling you the rules of what's going to happen. You're going to add the left side to the right side, right? A plus B or whatever. So anyways, that's just nice to look at it. Pretty functions like this are written with parentheses when you talk about them. Okay, a list of characters A, B could just be written as A, B, much easier. Phew, okay, we're getting it. You get pretty deep. Your arch nemesis, Churs or whatever, is going to try to steal your pizza. Uh-oh. Let's learn a little bit more about functions and passing them around. Try this. Okay, so map plus 1, 1, and 5. Okay, so let's guess what this is going to do here. Am I going to... Now, I'm assuming I'm going to apply, again, sort of backwards here, the operator plus 1. I'm assuming I'm going to get 2, 3, 4, 5, 6 here. I'm going to add 1 to everything in this list. 2, 3, 4, 5, 6. Okay, great. Here's where the magic begins. Okay, functions, functors, functoids, functi. Okay. So you just pass plus 1 function to the map function. You could try other things like these. Okay. I'm not going to click on them, although this is a wonderful interactive tutorial. Excellent job. This is where the academic, some good teachers have built this, I'm sure. Really enjoying this. So 99 times all these values here. Okay, so you get a bunch of huge values. I'll take that. They look correct here. Map, again, divide by 5. All these 13, 24. Now, am I going to get floating point values? Let's see here. I am. Okay, so I just have to worry about numbers. That's kind of nice in Haskell. Cool. Filter. Okay, all the values that are greater than 5. So 62 stays, 3 won't, 25 stays, 7 stays, 1 won't, and 9. Great. Get this list back. Very nice. Programming languages that don't have, map, filter, reduce, or at least have them in the standard library, you got to have these things here. These are fundamental ways to think about computation. Okay. Well, anyways, let's see. Note that a tuple is different to a list because you can do this. 1 : George. Okay. Let's see. You can only have a list of numbers or a list of characters. When in a tuple, you can throw anything into it. Okay, so lists, again, are the same type. So that's just so homogeneous data type, like an array or something. Let's see. You see that we can join 2 values together. But we can't do this with tuples. You can only write a tuple and then look at what's inside. You can't make new ones on the fly like a list. Okay, that's fair enough. Let's write our own functions. It's really easy. How about something simple? Let square of x equal x times x in square 10. Okay. Let's try to think about this, because last time we saw the in function, we had the expression here and then the body. But now we're writing our own function here. So let square, it's going to take 1 parameter, and it's going to be x times x here. And this is what we're evaluating, so we should get 100 back. Is that correct? Yes. Okay. Nice one. Okay, so now we're getting used to the let syntax. You define a function. You could read it as for a given parameter called x. Okay. Square of x is x times x here. Okay. Yeah, reasonable enough. That's the expression, and then this is the body that's evaluating it, or we're executing this. Okay. Really helpful, again, to think of this in as a separator of just like, slice the function here. Or at least that's how I'm interpreting that right now. Let others, some others that we can try here. Okay, so let add 1, x equal x plus 1, and add 1, 5. That should give us 6. Now if I do add 1 of like 7 here, what happens? Okay, it says not in scope. How do I declare a function? Okay, that's what we got to figure out. Or again, maybe this is not the right way to think about it here. Because I just want to evaluate like some expression here. So do I do in add 1, 5 or something? Okay, we'll have to figure that out. Let's try this other one out. Let second x equal SNDX in second 3, 4. Okay, let's think about what this is doing here. Second value in my tuple, that's all it's giving. Is it going to give me 4? Let's see here. Okay, it is. I guess second's defined, but I wonder if third, fourth, etc. are all defined here. Okay, let's go crazy and use square function with our map. Yeah, let's do it. Let square x equals x times x in our map, and we'll square. I mean, intuitively, you know what this is going to do, but let's try to break it down. Intuitively, we know it's going to take the squares of 1 through 10 and give me 1, 4, 9, 16, 25, 36, and so on. Okay, so this is the function x times x, and then we're mapping the square function, which is taking in this list as parameters here. Okay, that's how I'll explain it to myself. Now this I have to think about a little bit here. Enum, I'm taking in a number here. I guess enums I think of as in different languages like constants. Constant values, so some sort of list here in numbers, and it's giving me the new list back. I got to think a little bit about that here. Anyways, let's kind of keep moving along. Let there be functions. Hey, this has been more than 5 minutes, but it's been a good deal of fun. So I really am enjoying this. So cool. Okay, so you described a simple function square, and then you just passed in another function map and got back this list, exactly what you expected. Haskell's pretty good at composing things like this. Some other things you can try. Okay. Maybe we're not supposed to type all these out or something. I like to type them out. So we can do this in our example where we're adding 1 here. So yeah, I get 268, added 1 here. Ooh, a take here. Let, oops, what happened here? There we go. Let take 5s, okay, equal, filter, okay. Oh, take 5s, okay. Filter, okay, so I want to keep everything that satisfies this predicate here in takes 5, 1, 5, 2, 5, 3, 5. Okay. This should just have a bunch of 5s. Uh-oh. What did I do here? Oh, I spelled it wrong. Let's see. Take 5s. No, I did let take 5s. Takes 5. Ah, yes, I did. Take 5s. There we go. Okay, that's kind of neat. Let's see. Let take 5s equal filter equals 5 in map. Take, let's make this just a little bit smaller. 5s. Oh, interesting. In lists of lists. What's this going to do here? It's smart enough to figure out, are we going to get 2 5s back? We are. Okay. So it's going to be able to dig through those lists. Okay, so pretty powerful stuff here. Let's mess around just a little bit here. Again, this is how we learn stuff. Let, I don't know, t is going to be my function. Equal filter, let's say equal to 3 in, what do we want to do here? Let's map. I want to do like square or something else to like compose and do more. But I don't know how. Map. Should we do like squares? Well, I don't know if I have this function. Oh, let's just map. What am I thinking about here? 1, 2, 3, 4, 5. Do I still have my add 1 function here? So let's see. Here's what I want to do, like the test. Here's where I'm evaluating something. Where I want to add. This is going to be a great test here. Because I'm just doing 1, 2, 3, 4, 5. So I should have a bunch of 2s here and see if it keeps them. Let's see. See if I mess that up. Yeah. Okay, so I can't do that. I got to figure out if I need to compose that and have another let basically expression here in my map, but I wanted to add 1 to each of these and then just keep those. Okay, well, we'll figure out how to do that here. But anyways, okay. Did I get back what I expected? I did for these examples, and then I wasn't smart enough to figure out that one, so I got to keep going. One more example, 2 upper A. Okay, so we got some of these familiar functions. Exercise time. Easy. Okay, remember, characters are written like A in strings. Lists of characters are written like quote. I need to use 2 upper to capitalize the whole name. Chris, give it a try. You can do it. Okay, so 2 upper for the whole name Chris. Okay, so didn't like that. 2 upper. I need to use 2 upper to capitalize my whole name. Okay, give it a try. Well, I can do Chris, let's see, like this. Let's see here. Or let's see what happens here. And let's shove those things together. Oh, interesting. So that didn't work here. So 2 upper. I wonder if it just did the first letter here. Let's see what happened. Yeah, just the first one here. Okay. So I either got to do, let's say, let upper with some letter, I don't know, L, equal, let's see here, I lost my map stuff. You do some map function here. So basically I want to do like 2 upper in, let's see, how did I do my map here? In map, and just do Chris here. Let's see if this is a, let's see here. Something like that. Couldn't match type. Okay, but let's look at the messages here. Let's see. So I wanted to define or bind this thing here that took in a parameter. That's how I was thinking of it. Oh, was I supposed to do L here? Let's see if that made more sense. Nope. Okay. Oh, because I didn't apply a function here. Map. How was I using map before? Map and then the function after, right? Okay, yeah, map. 2 upper. Let's see if I'm smart enough to figure this out. Probably not. Oh, hey, okay, that worked. But did I do this in an efficient way? I don't know. Now, could I have just done... I mean, here's the other thing. Can I just treat Chris as well? Okay, so that'll also work here. Yeah, I took the long route here. So, okay, L is like the thing that I want to map, which means basically apply this function to all of these things here. Okay, let's see what I was supposed to do here. Oh, wow, map to upper Chris. Okay, that's a shortcut here. Interesting here. Yeah, I wasn't thinking here. Now, what happens if I just do L? Okay, so we still got to figure out this scope thing here. All right, but brilliant. We completed 4 lessons here. I'm kind of getting a feel for the language. So the first thing that I want to say is Haskell is not as bad as I remember it. I mean, again, last time I looked at this was 2011 in graduate school. So, 13 years go by. I guess my brain got a little bit bigger, or doing enough of these videos helped. So, another reason to look at all types of different programming languages, because sometimes, again, when you revisit stuff, it makes sense, right? We looked at OCaml. I've looked at other functional programming and done some other functional things in other languages that certainly help here. So since we're at the 48-minute mark, I'm actually probably going to continue this because I just want to do the pattern matching section. But then I want to look at the other language, and then I want to install it because we've done that on basically every one of our other lessons, and then we'll kind of call it there here. Okay, so we're making great progress here. Let's go over what we learned. Functions like map take other functions as parameters. Awesome. So we have higher order functions in this language, meaning that, that's what this means here, when you can pass one function as a parameter to another function. Languages like C and stuff, you can pass function pointers and stuff. That's kind of how you get away with it, but it's nice to just be able to pass a function. It's very clean. Functions like +1, greater than 5, and square can be passed to other functions. Defining functions is just a case of writing what to do with the parameters. Let's check out pattern matching, a way to get values from other values using patterns. So try this. Okay, let's do it. Let AB, so that's our tuple, 10, 12, in A times 2. Okay. Jolly good show. Okay. So you have the value 10, 12, and it matched it against a pattern AB. Okay. Simple enough here. A maps to 10, B maps to 12, and then I did a times 2 here, okay, for the expression here. Note, pattern matching A and B against 1 and 2 to get the A is the same as doing first 1, 2 like you did in the step 1. Okay, cool. A pattern always matches the way the value was originally constructed. Remember that ABC is syntactic sugar for A constructed with B and C and the list here. So you get the characters from a string with patterns. Okay, so let A, B, C here equal X, Y, Z in A. Okay, so this is going to give us back X. Yeah, okay. Because we have this pattern that we're matching against here, X, Y, Z. A is the first thing that we're constructing. B would be Y, and so on. Okay, so there we go. Okay, so let's go back to here. Okay, let's see. How do I continue here? Oh, I did the last thing here. Was that the last? Ah, okay. I wonder. Maybe I didn't type something in exactly right there or something, but anyways, the tutorial is continuing. Ignorance is bliss. You're getting into the tricky syntax, huh? I know you can handle it. Okay. If you want to see some of the values, you can ignore with the underscore. Yep, like this. So I've seen this in a few other languages, right? Underscore, just a sort of universal ignore stuff value here, right? Because we don't really care what's in the rest of our list here. We just want the first thing or the second here. I guess this is how we could define, which is kind of interesting. I'm going to change this up just a tiny bit. Let's say we just want the second thing, B here. And I could actually call it like second or something. So I guess it becomes pretty easy to define that if you don't have like third, fourth, or fifth, or whatever here. Okay, X, Y, Z, and B. Okay, so this should give me Y. And then I'll do it the way that they want it to proceed in the tutorial. Okay. So in fact, ABCD is a shorthand for this here. Okay, with the parentheses. I see. Okay. So let A equal X, Y, Z, and A. Okay, so that's an even more shorter hand. Try to get the A value from this value by using pattern matching. Okay. So let, oh boy, 10 ABC. Okay. Equal, and then I got to figure out the, let's see here. How did I do my first pattern here? So let A, B, and I want to get the A out here. Okay. Another one, I got to figure out how smart I am on the fly here. Well, let's see. The left side's the pattern here. So I sort of want to do, I don't care about the first thing. The second thing I do care about, and this is my pattern here, ABC. Okay, so I could say in X here. Let's see, this is gonna give me ABC back, right? Oops, parsing error, okay. Okay, let's see. Let's see. Underscore colon X equal 10 comma ABC in X here. Okay, let's see what I messed up. Let's just start by getting ABC. Let's see, that's the pattern we've been using. Here's the pattern equals the thing we want in A. Let pattern, okay, equal this. I have my X here, interesting. Couldn't match expected type. Oh, I guess I have to put this here. Because it's a list? No. Maybe on this side here. Does that match? No. Okay. Now let's back up a little bit. Let's say this is A, B. Oh no. Let's see. The colon here maybe is a problem here. Okay. Let's see here. Let's just do this with X. Okay, let's get rid of these parentheses. Maybe that's throwing things off. Okay, great. That gives us ABC. Okay, and I want just the A here. Now, how can I extract A? Let's see here. Well, how are we getting the first thing before, right? We were just sort of Okay, so we could just do like in this pattern X ABC here, something like that. Just do A. Does that work? Okay, so that works. I wonder if there's a cleaner way to do it though. Can I just use, what was it first? Something like that. Okay, interesting. Okay, so I think this passes. Let's see the way that they did it. Okay, yeah, you could just ignore everything here. So that's a little bit cleaner. Okay, fair enough here. Brilliant. Okay. Well, okay, some of you got pattern matching down. I got to practice more. If you're a bit unsure, here's some other things you could try. Yeah, I probably want to try these. And you could grab the whole pattern here. This is fun. You can grab a whole value and a pattern to match on it and have your cake eat it too. Let ABC at ABC. Let's just run this one here. Interesting. Okay. Alrighty. And that's the end of this chapter. That was easy. Okay, so now it's time. Okay, so we made it through. Not bad. We got a few minutes to kind of play around and install things. And it takes us to our documentation. Books, yeah, first one, Learn You Haskell, again, which is a really nice book. You can read it online for free. I do have a hard copy of it. But you know, if I get a lot of value out of a book, I like supporting the authors, although I haven't read it in 13 years. So anyways, let's go ahead and just get Haskell installed on the downloads here, and check out the Haskell compiler. And then from memory, just from a minute ago, let's see if we can just run something. Let's say use GHCup to install the Haskell here. Okay, I'll click on this thing. What is this? Okay, I trust you. Okay, so it's just gonna download a shell script and execute. Okay, that's fair enough. Actually, I like that. Okay, this is what it's gonna install. Okay, fine. Detected bash shell in your system. Do you want GHC to add the required path variable? Yes. Okay. Append it. That's fine. Do you want to install Haskell language server? No, I don't need that for now. But that is nice. I do like it. Let's see. What else is this? Do you want to enable better integration? I don't want to do this stuff right now. Okay. And hit enter. Okay, it says installation might take a while. That's okay. Let's just keep looking at some cool stuff. We got a few more minutes here. So what I can say about Haskell is I like it quite a bit here. This is pretty cool to see that there's a bunch of introductory materials here. Learn Haskell by building a blog generator. That sounds awesome. Relatively short, 150 page. I mean, I love seeing these different resources that are available here. Let's take a look at some of the community stuff while that's installing, because we usually like to do that. But there's Facebook, Reddit, okay, Wiki, and so on. Lots of meetups here. That's pretty cool. So if you're in one of these cities, that might be pretty fun to check out, and you know, an excuse to travel somewhere and check out one of these meetups here. There are lots of conferences and events. Okay, so there's some of these academic conferences, which is pretty cool. Now this is interesting. Non-academic conferences outnumbering the academic ones as well. And lots of different locations. That's pretty cool. I actually didn't know a lot about these here. Many of these I've seen because they're co-hosted with some, you know, conferences I used to go to more frequently. Yeah, this is pretty cool stuff here to see all these, you know, there's a pretty serious Haskell community here. You know, Haskell is one of those things too. If you truly know it and learn it, I suspect that's a boost on your resume. Because again, folks aren't just going around to learn. I mean, that's probably true of 90% of the languages I've covered here, right? Most folks know C and Java, and C++, maybe even a little bit, for as much as that language could be mastered. But that's kind of cool. You know, if you have some of the other languages from this series, and I think Haskell is one where it's, again, teaching you to think differently, right? You saw me kind of struggle in a way with things that I don't, usually use. Yeah, I'm familiar with map and all these stuff, but I got to think about it in a little bit of a different way here for how it's being composed, or the order, or different things, or the pattern matching stuff, which is kind of cool. So it is probably worth diving into a language like Haskell, just to challenge how you think a little bit about computation. Also interesting to see here that there's this University of Pennsylvania course. That's probably a good, that's a very generous offering, I should say, that's available. So tons of resources here. This might be one of the most, probably, of languages that we've looked at, even amongst popular languages, might have some of the most conferences of other things that we've looked at, which is kind of cool, and meetups. That's until we look at like C++ or something, which I know has tons of conferences. Quite a bunch of stuff here, which is cool. All right, looks like we've got Haskell here. I just need to type in for the REPL GHCI. Okay, let's see here. Wait, hey, that was a lie here. GHCI, let's see here. Okay. So maybe I need to relaunch my terminal or something. Ghost script, okay. All right, let's see. Come on, Haskell. Do us well here. Okay, yep, just need to launch a new terminal because it pre-appended to the path where this stuff exists. Okay, so we can do stuff like 2 + 2, let square x equal, all right, I'm already forgetting. So something in 10 square 10 x times x. Did I do this right? Phew. Okay, so I learned a little bit of Haskell at least today. And then let's see, what else did we have? The pattern matching, a comma b equals panicking. What was it here? A b what did we have, like 10, and then churs or something here. In a, okay, that's gonna give us back. Okay, cool. And in b, okay, great. So I learned a few things here. I do want to go to the documentation and look at a few more features that we saw highlighted. But okay, a testament to the language if you can get some of these things right on the first time. Something is sticking in there. Testament to a nice tutorial here. Really happy with that. Even under pressure, getting that right on the first time was great. All right, so I want to support them, donate to them and so on. Security, okay, interesting here. That's the first time, for as much emphasis as there is on security in programming languages, this has a security response team. That's really cool. I wonder if other languages have that, and we've just missed it, but this is the first one that I can recall in the series that has security here, so that's interesting. Okay. Okay, so let's take a look at some of the documentation here. Let's see if we can get to maybe the user. Okay, so this is for the compiler here. Okay, so we can debug programs. That's great. Let's see, we have like step debuggers and so on. I basically just want to see what their concurrency looks like briefly, if we can find like a small example. And then we'll end it here because, that pretty much covers most of the features that we kind of get to in an hour. Tutorials. It's probably in Learn You Haskell. Let's go there. Let's read it online. And let's see concurrency. Or parallel. Oh, maybe not. Okay. Probably not the first thing that you want to learn in a language. Okay, folds and stuff. All right, I remember this is a really nice book here. Okay, anyways. Types and type classes. Okay, I feel like let's skim a few more features here. We didn't get exactly to check out all this stuff here. Okay, we got some IO stuff. Maybe we're just not going to get to it. That's okay. Maybe we can do a round 2 if the people demand it. That'll be good enough here. Alrighty, folks. So with that said, let's just go ahead and wrap it up here and kind of wrap up our review of Haskell since we've gone over an hour here. Really a brilliant language, right? It's had a 30-plus year history, 34 years since 1990. There are standardizations of the language. There's lots of conferences and a really big community around the language, both online. I think, again, this is a language that has a lot of really enthusiastic developers. You can see from all the organized meetups, for instance, which might be great places to learn. I'm sure there are various levels of introductory talks at those types of things, as well as at the academic conferences. And again, I think Haskell is just one of those languages that you have to, or you should look at some time in your life here as a programmer. And there goes my camera saying it's time to go. Because again, it helps you think differently. Okay, so I think that's the main goal here with Haskell. So again, really impressed with the Haskell project. Really impressed with everything from the presentation, the talks, the videos. You can tell people are very passionate about this language and its design and making sure to get things right. And you're seeing real world use cases. I'm quite impressed. The impression I had as a student was this would be a good thing to learn. It'll make me a better programmer. Now I believe that, and I certainly believe that whether you choose Haskell or a different paradigm from what's your normal things. If you're always doing object-oriented stuff, try a functional language. Try one like Haskell. Haskell is the one that is purely functional, so it's pushing to the sort of extreme of functional programming, I guess. You can argue if that's how it's supposed to be or these types of things. Those are other discussions, I suppose. But again, overall, give the language a try. Try the web demo like I did. Try to follow along here. Try to create some little examples. I think it'd be fun to build some little like guessing games or those types of things here. And again, I think Haskell is really a really interesting language. I was quite impressed with how easy it was to set up on the desktop as well, which is great. Install script that just worked. And again, the ecosystem seems very mature, and there is a lot of interesting tooling, whether that's the testing, the packages, or the modules that are available as well. I know there's a foreign function interface, right? We saw things like SDL for graphics and stuff that you can connect to. So really a neat project, really a lot going on for it. And again, I'm quite impressed, and probably studying Haskell will help, make sense of all the different programming language things we talk about in this series. Again, it'll be helpful for me as well at some point to do more of that, and I think I will. So anyways, with that, folks, I'll go ahead before the camera tries to shut me off again and just end it here. Thank you, as always, for your time and attention. Please let me know in the comments if you're using Haskell, have been curious, what you've thought about it in your uses, or just trying it out. I'd be really curious to hear about again, Haskell in the real world, or otherwise your experience as a learner with this language, and if it was similar to mine. Alrighty, folks, with that said, thanks for your time and attention, and now I'll look forward to seeing you in the next episode.